Okay, so PET scan. So basically, P in this term represents positron. And if you remember, we studied about positron in AS, right?
Yeah, I
Of
remember that. It's
electron.
like what's emitted instead of a neutron, right? Like when the anti-neutrino, I think.
Yes, basically we have electron. Electron have negative charge, and we use positron. Positron is the opposite of electron, like anti-particle of electron. Emission, and same T represents tomography, just like in CT scan. Okay, so again, the first question, why we are using this? Because already we have so many processes to scan and all the things. So the reasons are, it also gives you 3D image, just like CT scan, and it is very precise in locating cancerous cell. And the third thing, we can also observe the brain functionality with the help of PET scan. The brain functioning can be monitored. So in other scanners, we don't have the same ideas. That's why we are using a PET scan. And the next question is, what is PET scan actually? So the basic thing remains the same, that it is a 3D medical imaging technique, simple 3D medical imaging technique. And just like we mentioned, positron. So positron means we have one electron, and one positron strikes one another at some speed. So an electron and positron strike one another. And the third factor is about attenuation process,
Okay.
or we can say that when two opposite, like both are opposite to each other, like positron is the antimatter of electron, And in particle physics, we already studied when we combine this type of particle. So there is a process takes place which is called annihilation, right?
Okay.
So that process can also occur when electron and positron strikes with each other. So they starts to annihilating one another to produce pair of
What would the product be? Like, what would it produce?
first product is the gamma ray photons.
Gamma ray photons?
Yes, because gamma ray is already is like called electromagnetic radiation, or it is based upon high frequency. So it produces pair of gamma ray photons.
So, like, if you think about it, almost all of these methods use gamma rays. Like, maybe not initially, but they come in later on.
Because in the initial stages we studied about X-ray and gamma rays. So the main purpose in medical field is to detect or to treat cancerous cells, right? So that is the main
Mm.
purpose. Uh, Other purpose of X-ray is to detect like or to diagnose any defect in the bone. So that is other process. But other than that, if we work on advanced level, so main purpose is to treat cancer cells. Because in
Okay.
yes, in most hospitals like that works on this cancer patients, so they use this technology. They have gamma knife in their hospitals. They have these all type of scanner over there. So that's why they are using these devices, because that is the main purpose. Because for other diseases, we have definitely other medical or medicines, so that can be treated with the help of medicines. Because but these type of patients cannot cure with the help of normal medicine. So that's why they require some special treatment. And in old ages, like in old times, when medical field don't have this type of scanner, so they use very like painful process, just like endoscopy and all these process. But that process is very painful because we need to pass a camera and tube into the body with the help of nose, mouth, etc. to diagnose or to observe internal organs. So that is very painful also, and that is not very accurate. So that's why we are using this wireless incense, we can say. It can pass through the body and it can treat without any physical changes in the body, right? Because first we need to cut
Right.
certain part and then we need to insert pipe into the body, then we like take stitches on it. So that is very difficult, and patient also feels very danger in this type of process, because first doctor cuts that part and then insert tube into the body and then make stitches on it. So not every patient is able to face this type of treatment.
Okay, so it like depends. Like you have to see if they're up to the part.
Yes, basically it is just like X-rays. In X-rays, we just stand in front of that X-ray machine and X-ray passes through our body and we feel nothing, right? So that's why it is
Yeah.
very cool, and it is not very like seems very dangerous, that it seems very dangerous and we are not able to be a part of this experiment. So that's why these experiments are like wireless. We are not able to see any scissors, knife, etc. And it is very simple process.
Okay.
And since we got pair of gamma ray photons, so both have equal energies and opposite direction. And finally, detection used to find location of tissues to be analyzed. So this is the main purpose, and this is the idea of the PET scan, how this actually works, or what is like the journal process of PET scan and why we are using it. And if you further discuss about the detail working, because right now we mentioned that there is annihilation process and electron positron collides with each other and they moves in opposite direction. They have equal energy. So still we have so many questions in it that how this process takes place. So if we consider detail working of a PET scan, that how it actually works. So first of all, we need to prepare a tracer for scan, because in radioactivity chapter, you know that we study if we want to detect a crack in the pipe. So we need to add certain radioactive material in the water so that water passes through the pipelines and it emit out radiation. So with the help of that streamline of water into the pipe, it gives you the radiations coming out from the pipe, and it will be easy for us to detect that radiations coming out from the crack. So you will get greater reading over there, right? So in the same way, when we are going to pass any radioactive material, just like gamma rays, we are getting gamma rays. So the first part is to prepare a tracer for scan, because when there is a certain radioactive particle or radioactive material in the body, so scanner detects that particle, that from which place it is actually passing and through which organ it is passing or through which particle it is going to be collide. Okay.
Okay.
So the first idea is preparing a tracer for scan. So in the preparation, we have some tissues absorbs a specific type of compound or molecules, because we know that in human body not all tissues are able to absorb anything, just like x-ray. If you consider x-ray, so x-ray can pass through the tissues very easily. So that's why it is very important to use a type of radiation or whatever the process we are using that can be absorbed by the molecules, because if the molecules in the body absorb that thing, so then it will give you result in the output, otherwise it will be untraceable, right?
Okay, so like they put like for example how they have like those neon detecting like they have like medicines which have neon in them so they can be detected and stuff.
Yes, exactly. So we, the doctors use a specific type of medicine or liquid or whatever the tracer they use. So that is not very important right now because we are not going to discuss very detail about it. So definitely in the same way, that tracer or that neon, whatever the liquid we are using, so that can be detected with the help of the scanner. So
Okay.
basically, yes, in PET scan, it use radiation of these molecules. And definitely, main purpose is to treat cancerous cells. So definitely, these radiations are radioactive, and these molecules are also radioactive. So these molecules are radioactive. Now, if we talk about some devices name, like the components name for the PET scan, so there is a component which is called a cyclotron. So basically, cyclotron is a device that is used to make these tracer molecules, right? So basically, how that cyclotron makes these tracer molecules, it smashes high speed photons into ordinary atoms, and that turns into the isotopes of radioactive material. So basically, after this, the next thing is cyclotron, and basically it is a device that is used to make these tracer molecules. So initially we are talking about these tracer molecules. So basically cyclotron is the name of the component that produces these tracer molecules. And then further, in this cyclotron, it actually smashes high speed photons into ordinary atoms, turning those isotopes into radioactive ones by changing number of neutrons inside their nucleus. So basically, the working of the cyclotron is simple. It actually smashes high-speed photons into ordinary atoms, and we are using basically isotopes. And in isotopes, we know that there are same number of protons, different number of neutrons. And when photons strikes these isotopes, so it depends upon the number of neutrons. That if your number of neutrons are greater or if your number of neutrons are smaller, so it will give you different results, right? For example, if neutron number is less than proton's number. So we will get beta negative. And if neutron is greater than proton, so we will get beta positive. So it depends upon the scenario. If we require beta positive, so we will increase the number of neutrons. So this cyclotron process according to this. But let's suppose if we want beta negative, so cyclotron process according to the value of beta negative, right?
Okay.
Yes. And again, we are using radioactive materials. So definitely for radioactive material, we need to use short half-life. This is another important thing.
That they need like half.
Yes, short half-life.
Okay.
So I,
That it can like be done. So like this whole process can be done quickly.
yes. Because if we use long half-life, so even after the process, that radioactive material remains in the body.
Yeah, like even if the person dies.
Yes, and that will damage other cells also. So you need to repeat that process again. So that is not good.
So like what would be considered like short half-life? Like is uranium like considered? Because I know carbon-13 takes very long.
Yes, basically we have cobalt in like many questions. We observe that we use cobalt because it has half-life of 6 hours. So that can be used in most of the process because in many questions in our syllabus, we in IGCSE even we got that material because we never discussed very detailed about the materials that what material we are use. The main purpose we only discuss is that either we are using short half-life or long half-life because their half-lives are already calculated. So we can just check the table and use that material and these are like designed already. So we don't need to like study that again and again and use them because that are already designed for us. So we just need to copy paste the thing, simple.
Okay.
Just like in periodic table, we already have discovered elements, so we don't need to again rediscover it because that is already discovered, so don't need to rediscover it. Just use exactly the material we want for our process. So sample is prepared. And one more important thing, we are using short half-life, so definitely we need to prepare this sample few hours before this process. Otherwise, it loses its half-life to the lower value. For example, if somebody needs to perform this PET scan, so at least 2 hours before this scanning, they need to prepare this sample.
Okay. Got it.
Yes, and there are some examples also, if you just want to know about some examples.
Okay. What would they be?
So, for example, they use fluoro, number one, deoxy, glucose. So, this is one sample. Second one is protein. And the first category is from the sugar. This is from the sugar category. So these are some examples for the sample that they use for before that PET scan to prepare it.
Okay, so like, can I memorize these? Because like, what if they ask them, like, would they ask him like for a mark?
No, they will not ask for the exact marks in the question because this is just for example. We just need to know how it actually works in journal.
Okay.
And the next process after cyclotron, because this is the whole information related to the cyclotron, because cyclotron is a device that is doing all this process. So after cyclotron, when this molecule is absorbed, location of that part is found. So after making up that sample, when it passes into the body, and definitely when this is absorbed by any specific tissue that we want to diagnose or want to treat, so definitely the location of that exact part can be identified, and then tracer is purified.
How, like, should we know this or no? Like, how it's purified?
Okay. Basically, tracer is purified from less useful molecules.
So, like, the body itself?
Yes.
Okay.
Because now it depends upon the case, like what type of case it is and how much quantity is required, or what is the amount or the dose that we need to give to the patient. So it depends upon the case, right? So that's why we are
Okay.
writing just journal information. So tracer is purified from less useful molecules and amount of radioactivity is checked. So this is the process related to preparing a tracer for a scan. So this is the whole information that how this tracer can be prepared for the scanning process. So cyclotron is a device that is actually making up these tracer molecules. And this is the journal process going on in this cyclotron, right?
Okay, right.
Now, the next step is when that tracer molecule is absorbed by a specific part of the brain or whatever the tissue that we want to analyze. So then what happens? So for example, during PET scan, so the first information is when tracer molecule is absorbed by the part of brain that is to be analyzed. The molecule's radioactive part decays and it will emit a positron. So when it is absorbed by the part of the brain or the tissue that we want to analyze, this molecule or the molecule's radioactive part decays and it will emit a positron. So it will emit a positron. And secondly, this positron collides with the electron, just like we discussed in the start, that both electron and positron strike one another at right speed. So the second process is the positron collides with electron in the surrounding, and emits two gamma ray photons traveling in opposite direction. So we already discussed about, we already mentioned this main concept in the start, that this will happen in this PET scan. And after this, the third process, there is a ring of detectors placed around the patient, and that actually detects gamma photons, and then a line of response is mapped by detecting those photons. A line of response is mapped by detecting those photons. So just like a CT scan, we have a same type of structure. There is a like bed in that circular ring, and in that circular ring we have detectors in different positions. So when radiations pass through any angle, so that detectors can detect them easily, right?
Right, okay.
So it is the same process.
Okay.
A small degree of uncertainty
So in the PET scan, what happens is like the detectors will detect exactly like they will like pinpoint where the
Yes.
like trackers are placed, and using that then and that and with the combination of like the gamma rays, they'll like make the image, the 3D image of that specific area.
Yes, exactly. So it will give you more precise, more accurate result as compared to any other scanner. So a small degree of uncertainty exists in detecting the exact location and patient are advised not to move. So this is the whole scenario for PET scan. So this is the whole process for this PET scan also, and it is also simple and similar like the CT scans that we discussed. It passes through one side and then detected on the other side, but only the particles we are using are different as compared to the other. And further, if we consider some past papers questions, right? So let's see that is there anything is still left in this chapter that we missed during the discussion part? Okay.
Okay.
Okay. If we continue with the past papers questions, so let's see from the latest one, because in old papers, some questions and some parts are from the old syllabus. So if we first consider the new questions first. Okay, so we discussed this question related to intensity part, and before that we have, okay, so this question is related to PET scan. Okay, so in this question, PET scanning obtains diagnostic information from a person, and the information is used to form an image. PET scanning uses a tracer. So explain what is meant by a tracer. So basically, in simple words, because we only need to write for 1 marks, and over here we discuss about tracer, very much detailed about the tracer. So basically, in simple words, we can say that is a simple radioactive nuclei that is absorbed by the tissue, and we actually study about that radioactive nuclei absorbed by the tissue, right? Because in start we discussed preparing a tracer for scan. So some tissues absorb a specific type of molecules. So this is the main idea, that we need to prepare something that is absorbed by that specific type of tissue, in simple words, right? For example,
Right, right.
if we are working on tissue A, let's suppose. So tissue A absorb different type of material. Then we have certain tissues B, C, D, etc. So they absorb different type of materials. So the main purpose is to prepare some type of radioactive nuclei that is absorbed by the tissue, or like a specific region in the body that we are working on. So we can say substance containing radioactive nuclei. And in marking scheme also you will get exact the same idea, because this is very straightforward questions. There is nothing detailed, there is no calculation required in it.
Okay.
So even if you check the marking scheme, so you will easily relate with your paragraphs that we discuss in the notes. So it will be easy for you to identify that which point actually links with this first part of the question. So that is absorbed by tissue. And second part, it also involves annihilation process. So what is meant by it?
It's kind of wait. So it's like when the particle interacts with the like the anti part of it,
Antiparticle? Yes. So
and that like make energy.
exactly. So a particle interacting with its antiparticle, so it converts into energy. And in second part, state the name of the particles involved in the annihilation process. So we already know about the name: electron and positron. And we need to calculate the total energy released in one annihilation event in part B. So basically, this is related to information that we already studied in AS. There is a formula which is called E equals to mc square, right?
Yeah.
So according to E equals to mc square formula, we need to use 2 mc square, because we have two exactly same mass, only their charges are different, right?
Right, okay.
So their masses are same. So it will give you the final answer. Okay.
Okay. And like the mass which we use is like the change in mass, right?
Yes.
Okay.
And further, they are asking about the wavelength of each gamma photon released.
Okay, so what we do is would we use like the the one which is like lambda equals to 2hc, that one?
Yes. So basically, lambda is equals to 2hc over E.
Okay. That's like we get that formula from like deriving it from E equals to 2hc over lambda, right?
Exactly. Because you know about the basic ideas, that's why AS knowledge is very important for A2. So it helps you a lot in A2. Otherwise, you need to revise that concept again. It will take more time and it will also like uh very difficult
I
to.
don't remember for A2, but like I remember studying this in like nuclear physics.
Yes. Okay.
I mean in
So
A.
in part D, explain how the gamma photons are used to produce an image. So this is only for 3 marks. You need to explain how gamma photons helps you to produce an image. So in process we discussed. So during this process, what happens when molecule is absorbed by the part of brain? So that is analyzed and it decays into positron. So this is the first process we already mentioned. Now they are asking about the gamma photons directly. So from the second point, so in second point, you can see the positron collides with electron in the surrounding and emits two gamma ray photons traveling in opposite directions. So first of all, they are traveling in opposite direction. Okay. So you can mention this whole point that positron collides with electron and it emits two gamma ray photons traveling in opposite direction. Okay.
Okay.
Positron collides with electron, emitting, because their main purpose is not to ask about the production of gamma rays. They are directly asking how produce it produces image, right?
Right.
So it positron collides with electron emitting two gamma ray photons traveling in opposite direction. And in the second part we discuss there is like a ring of detector that is outside of the body. So outside of a body we have a circular track around the body in which we have detectors to detect the radiations. So definitely these gamma ray photons are going to be detected by the detectors outside the body. So that will be the second point. These gamma photons are detected by detectors in the ring outside the body. And then the last point, a line of response is mapped by detecting those photons and that will give you exact image of that specific part. Okay.
Okay.
So gamma photons arrives at different, and it helps to locate
Like the exact position of.
Yes. So there are different options to phrase your answer because you already have very detailed points given in your notes. So you can relate easily with the help of your notes. So
Okay.
this is for 9 marks and very simple, straightforward question. Because only C part is calculation based. Otherwise, rest of is just theoretical base.
Okay.
And this is related to again extra photons, the same formula for intensity. In this part, they are also asking about a piezoelectric transducer and specific acoustic impedance. So you need to write down the definitions. We discussed this one in ultrasound and X-rays detectors, right?
Yeah.
And this is related to CT scans advantage and disadvantage. We already discussed them. So these are the advantage and disadvantage. You can just simply copy paste for 1 marks each. Sharpness, contrast, outline the principles of CT scanning. So you just need to write down whole process that we discussed in CT scans, right?
Right. Okay.
So mostly you observe that questions are from the same part and the same information that we discussed. So we can easily practice, you can easily solve questions from the past papers of medical imaging because these are very straightforward. You don't need to link any other chapter or any other concept with the topic of the medical imaging. So that's why it is very easy for you, right? As compared to other chapters.
Yeah, it is.
So you can go through past papers by yourself also and let me know if you find anything different or anything that you are not able to understand in that. So next time we can practice the combined papers from electromagnetism and medical from 2023 and 24 because this booklet is till 2022.
Okay.
Yes. So from 2023 and 24 we will practice next time. Till then you can practice topicals from this one. And for 2023 and 24 questions, we can practice in class combined for electromagnetism and this medical imaging. Okay.
Okay, inshallah.